Okay, so once again, what you have to consider for trig equations is that there are more than two answers, like you might recall from CAST rule or cofunctions or whatnot. Okay, whether you use just circles on a Cartesian coordinate or you actually draw the trig function, it will help you identify how many answers you are looking for, so that if you only have two, for example, you'll be like, wait a minute, something's not right. I'm missing something, and it gets you to think deeper about it. So for this, the question specifically asks you for a equation. When is this statement true? In a interval between negative pi to 2 pi, which means a full circle and a half a circle in the negative direction. By functions, it is the green portion of this entire periodic function, right? And so we are expecting ourselves to see 4. Now, the next example I'm going to give you is not one of the special triangles. And so you will need your calculator and do radians for this, okay? So this one, if you want to put a little star and say, not special triangle. Okay, just to show you, like, even here, you still do the same things. Even if it's not a nice angle, you use CAST rule, you use whatever techniques that you've had so far. I'm going to simplify it just to get the ratio all alone, because after all, that's where the x is. So I am going to divide both sides by 3. And I will subtract both sides by 1, which gives me negative 1 over 3. Okay, so also consider, that's a huge interval. So if I were to graph it, it would be 1, 2, 3, right? That's 2 pi, or one cycle. That's another 2 pi, 1 cycle, and then there's half a circle, that's 1 pi. That's a lot of stuff going on. Oh well, this is actually a tangent, so this is for science. Sorry. Maybe I shouldn't have done that. I just realized. Right, I'm just trying to show you how many loops around we're gonna have to do. Sorry about that. Here we go. If I were to use CAST rule, notice that the tangent is a negative of 1 over 3. If I were to use CAST rule, using CAST, if tangent x was equal to positive 1 over 3 in quadrant 1, what would my x actually be? Well, here's where your calculator is going to come in. If you do inverse tan of 1 over 3, where's my calculator? Pardon? No, it has to be in radians. So in radians, if you do inverse tan of 1 over 3, in radians, you should get 0.322 radians. Oh, there you go. Oh, okay. What you're doing is that, right? So if this is supposed to be my radians in quadrant 1, that is right here, what would my angles be in quadrant 2 and quadrant 4? So what I'm trying to say is the related angle is 0.322. What is my angle for quadrant 2? So since tan x equals negative in quadrant 2, my angle would be, quadrant 2 is pi minus the related angle. In quadrant 4, my angle is 2 pi minus the related angle. So what are the two angles I'm dealing with? Right? So let me back out a little bit. So that's a lot of stuff that you have to consider. Before actually writing out all the possible answers, let's talk about this. Once again, I have removed everything I could except the trig ratio to the right side, getting me tan x equals negative 1 over 3. Negative 1 over 3 automatically tells me that it's in quadrant 2 and 4, but we'll get to that after. If it was a positive 1 over 3, in other words, in quadrant 1, what would my angle be? Well, it should have been 0.322. But since the tangent is a negative value, it's going to have to be quadrant 2 and 4, which can be calculated in this way. It's a lot to, but again, it's all alluding to little skills that we've done before. So let's do this. So for the interval of my normal circle, in quadrant 2, my angle is pi, so 3.14, minus 0.322. What is that? Pi minus 0.322. I got 2.82 radians, rounded. Follow along with me and see if you can calculate that as well. In quadrant 4, my angle is 2 pi minus 0.322. 0.322. There's all right. 0.322. Which is 5.96 radians. Okay. Those are my two answers. What do you think? So far, so good. Any questions?
What is the answer?
So my two answers for now are there, in quadrant 2 and quadrant 4. So this up to here, I would say is, other than the fact that it's radians, that is basically grade 11 material. Wouldn't you agree? You've used cast rule, and you've calculated the actual angles using your related acute angle. The reason why this is a little bit up is because you now have to consider in the back of your mind the overall interval, the interval that they gave you from the beginning, and that is negative 2 pi all the way to 3 pi. Let's do the positive. We have covered 0 to 2 pi. So now we need to consider from 2 pi to 3 pi. From 2 pi to 3 pi is basically, after one full circle, it's an extra here. Long story short, which quadrants do I cover twice? Quadrant 1 and quadrant 2. Which quadrants do I care for in this question? Quadrant 2 and 4. So if I'm going to go through quadrant 1 and 2 only for the second revolution, I only have to worry about quadrant 2 in this interval. Yes.
Are we also going to cover the negative 2 pi to 0?
Yes, we are. So let's do, I'm just trying to break it down. If you can do it in your head, amazing. And in fact, I encourage you, I'll show you another way you can do it in your head if you want to. But for now, I'm just doing it visually so that you know I only need to do quadrant 2 one more time. So how do we calculate the angle of quadrant 2? You already know that it is pi minus 0.322. But this happens after a full rotation. Right? It's a full 2 pi and then a full pi before I subtract my related angle. And so essentially, if you have this, we already know, because these two are coterminal. So actually, from now on, if you notice that it is coterminal, you don't have to actually recalculate it. Being coterminal, you take this number right here, just add another 2 pi to it. Does everyone understand that? I'm just trying to make it so that you don't have to do extra work. So 2.82 plus 2 pi is approximately 9.10 radians. And I don't have to worry about quadrant 2. Sorry. I should do that. Which I hope will make this one easy. What do you think? Again, this is not going in that direction. I'm going in the reverse direction. But it shows me that I'm still going to cover quadrant 2 and quadrant 4. So I will need an answer for quadrant 2 and quadrant 4. But instead of actually trying to calculate a negative 2 pi and going backwards and doing a funny equation like we did last time, right? Like in a weird one in the previous example, why not just use our knowledge of coterminal angles? So what do you think? There. In quadrant 2, the angle is supposed to be 2.82. What's a coterminal angle in the negative direction? You don't have to tell me the answer, but what would you do? How do I calculate the coterminal if I'm going backwards? Yep.
Add it instead of subtract it from the 2 pi.
Add it instead of subtract it from the 2 pi. I still think you're thinking about it the way we did it yesterday. What I was thinking about is in quadrant 2, it's going to be 2.82 radians, but a coterminal angle in the negative direction would be subtracting a multiple of 2 pi. Just go backwards one circle, and you would get approximately negative 3.46 radians. In the same way, this angle is supposed to be 5.96 radians, but if I go back 2 pi, I will get negative 0.322 radians. And that sort of makes sense. Consider this. I'm going to look at quadrant 4 in a normal circle. Okay? This pink area is 5.98. And if you subtract it from 2 pi, this portion right here is 0.322 radians. Right? Because look, 2 pi minus 0.322. So if I make a triangle here, that triangle that I have right there is actually exactly the same as the one I have here, except instead of going in the positive direction, I went in the negative direction by 0.322. It's the same triangle. I know you can't see that because my camera, but I hope you see the similarity. You can do it algebraically by actually calculating it the way you want to, or you can use coterminal angles knowing that this is 0.3. You can compare images in your sketches to come to the final answer. There's a lot of different ways you can do it, but as the examples get more and more complex, well, that I'm going to see what method you would prefer to use. I'm going to try to show you as many as I can. Any questions on this? Yes?
So within each interval that we did, each of those count as right answers?
In fact, all of them have to be there to be a complete answer.
So yeah.
Just cross your fingers and hope that I don't give you a ridiculous interval for your domain. So you don't have to have too many answers. Okay? Any questions? For now? I'm going to try to do as many examples as possible. No? Alright, let's keep going. Let's push through. Example 3. Example 3. Okay. Are you sure there are no questions so far? You just have to practice them. Yes? Example 3 might challenge you a little bit. It's not that it's difficult, but some of you, if you don't practice it, you'll forget something. And let me explain. It says, write a general solution for the trig equation 2 sine theta cos theta equals cos 2 theta. General solution means I'm not giving you any intervals. I want you to give me a statement that covers all possible answers. So let me simplify this. 2 sine theta cos theta is equal to cos 2 theta. Wow, that doesn't help us at all. That's not difficult though, because you have practiced your trig identities. What do you recognize? There's a method to the madness. Clearly, this is way too hard. There's no way you can find an angle of theta that satisfies this in one go. But take a look. 2 sine theta can be rewritten as a double angle formula. Okay? And now, remember, this is not trig identities per se. This is an equation, and I'm trying to solve it. So I'm going to bring cosine to the left side by dividing both sides with cosine 2 theta. Remember? This isn't an identity. I can do this. It's an equation question. I'm trying to solve it. I'm not trying to prove it. I'm trying to solve it. I'm going to rewrite this as there. All right. Using your special triangles, there is one point, at least within 90 degrees or within pi over 2, where tangent equals 1. Pi over? Take a guess. 3, 4, or 6? Pi over 4. Good. Okay, don't solve it there. This is where some people will get confused. Do not divide out 2 theta, or the 2 yet. Sorry. Do not divide out the 2 yet. Yes.
How did we find the pi over 4?
Because we did some magical hocus pocus. Okay. Tan if I have tan x equals 1, there is an angle within pi over 2 that gives you that ratio. Tan x is equal to y over x. In other words, it's 1 over 1. When do you ever have the adjacent and opposite sides being 1 and 1? Pi over 4, yeah. 45 degrees, 45 degrees. Okay? That's where we get it. So don't divide it out. Pretend, if it confuses you, pretend this is actually one angle. Pretend I say tan alpha is equal to pi over 4 or something. Okay? Do not divide that out yet, and I'll tell you why. If Okay. Okay. So from here, all right. So I said do not divide it. Okay. So since tangent gave me a positive value, that means it must be in quadrant 1 or 3. With me so far? Okay. So if the angle I'm dealing with, is in quadrant 1, so I'll do quadrant 1, 2 theta is going to be pi over 4. But if it's in quadrant 3, 2 theta would be pi over 4 plus an extra pi. It would be 5 pi over 4, right? And in case you're wondering, remember, Sure. I think I just jumped the gun a little bit. Let's go back. We found that whatever angle we're dealing with right now is pi over 4. However, because 1 is a positive, it's not just pi over 4, it's another angle as well. So in other words, you can say that 2 theta of pi over 4 is my related angle. Pi over 4 is going to be is that. But we also know that will also give us the same answer. So what is that triangle? Pi over 4 plus an extra pi. So we have this versus that. Because it's a positive, it has to be quadrant 2, or it has to be quadrant 1, or it has to be quadrant 3. If it's quadrant 1, the angle is pi over 4. If it's quadrant 3, the angle has to be pi over 4, this little piece, plus a full half a circle, which is pi. It is 5 pi over 4. Okay? But the question didn't say anything about a single revolution. It said, give me a general equation. So basically, in quadrant 1, it could be all pi over 4s plus any multiple of, in quadrant 1, the angle could be pi over 4 or anything coterminal with pi over 4. So, 2 pi is going to be actually pi over 4 plus k belongs to integers, like our very first example. Right? And same with 5 pi over 4. And so that is what my answers should be. But because it's a 2 pi, something's going to happen with this. Let's go back to transformations. When there was a number multiplying with my angle, what does that turn into? What does that represent in a transformation on a graph? Scratch that. Backtrack. If there's a number that's multiplying within the ratio, is that an A, K, D, or a C? It's a K. 2 means I am making the period compressed. I'm multiplying everything with a half. Take a look at what happens to my answers. When I divide both sides by 2 now, it becomes pi over 8 plus pi k. When I divide the answer now, theta is equal to 5 pi over 8 plus pi k. So instead of every quote-unquote 45 degrees, I get something happening every 22.5 degrees, which makes sense in a transformation perspective. Okay. I don't want to get too... I don't want to add another layer to this, but just as a sort of a fun thing, what do you notice between... What is the difference between this line and this line as a rotation? It's 180. So in fact, I could probably group this together and say just one statement. Instead of revolving 2 pi and revolving 2 pi, I can say, hey, take this, and every time I revolve 1 pi, I get the triangle that I'm looking for. But let's just leave this as it is, and once we get comfortable, we can start taking some shortcuts. Okay. I know this is a lot, but once you start seeing it and trying it and doing more and more, you'll see that the process is still always the same. As a recap, I have isolated, or I have simplified the equation so that I can figure out what the angle is, just like we did in the previous questions. And using that as my, using that to figure out what my related angle is, so the acute related angle, we are able to figure out what quadrant this answer would appear. Once we do that, we use cast rule and we give our answers. Okay. It's constantly going to be the same thing. The only difference between this year and last year would be this thing called a general equation, or just giving more than one possible answer. Okay, let's keep going. We'll keep going until we get a chance to decompress. Consider this, everyone. This time, my revolution is going to be 2 circles. And they ask you to solve sine squared minus sine equals 2. I'm going to rewrite this to see if a strategy pops up for some of you. See if that looks familiar. I'll give you like 30 seconds. Yep.
Is it like ax squared minus bx plus
Mm-hmm. It is basically a quadratic. It's a quadratic. But obviously it's not as simple as that. It's a little hard to look at it just as a quadratic. If you can, amazing. But if you can't, consider this. Let a equals sine x. That means I have a squared minus a minus 2 equals 0. all of a sudden it's a lot easier to factor. We have a minus 2 and a plus 1. What does that mean? A could be 2. A could be negative 1. Which means sine x could be 2. Sine x could be negative 1. I'll let you copy and let that sink in. Where do we go from here? Or rather, as a recap, anytime you see something with sine squared with a sine, or basically a ratio squared, a ratio that's not squared, think about factoring as a solution, and you get ourselves a substitution. What's next? What do we do all the other times? Well, let's figure out what x is that makes sine equal 2. Yep, it's inverse sine. What did you get? Yeah. Error. What? But that makes sense. What's the highest and lowest point a sine curve can go? 1. So this is automatically rejected. Yep. Which brings us to this. I'm going to challenge you right now. Sine x equals negative 1. Step 1. Find what quadrant we are in. Okay. Number 2. Identify angle. Z. Okay, so what you might need to do is either, I won't, you know what, I'll just leave that to you. I'm not going to give you steps for that. Just identify angles and then apply to domain. That's essentially it. See what you can do. I'll give you a couple of minutes. Sine x equaling negative 1. Just think a little bit about what angle that might be. See if you can find it. Apply to the domain. In this case, it's 4 pi, so 2 circles. If you're not quite sure how to do it based on quadrants or special triangles, maybe the graphing might help you. Yes?
What if it's not in a quadrant?
Good. It's not in a single quadrant, rather. What angle gives you negative 1? So this would be 0, 1, 0, negative 1. So it's not actually in a quadrant, it's on one of the axes.
Wait, 0, 1, 0, negative 1?
Think about it as a graph. Here, I'll give you a hint, everyone. Sine curve. Remember? 0 to 1 to 0 to negative 1 back to 0. There's only one spot on a curve that reaches negative 1. What angle is that? Or 3 pi over 2. Okay, so find out what quadrant we are and identify the angles. Sometimes you will get something a little in the gray area like that, but it doesn't mean you're doing anything different. You're still trying to find the angle and then apply it to the domain. Yes?
So what quadrant is 270?
Well, it's right between 3 and 4.
So what do you put then?
Negative 90.
That's why-
You can use 3 pi over 2. Knowing that it's only one angle and not two angles, right? There's only one answer in the entire revolution. That's it. You don't have to go any further.
You don't find the quadrant answer?
Well, at least from 0 to 2 pi, the answer is just 3 pi over 2. I don't have to do cast rule because there's only one answer. There's no two triangles that we have to worry about. So for this one, in 0 to 2 pi, the angle is just 3 pi over 2. I don't have to do cast rule. I know this to be a fact. But the question also tells me to go another full revolution. And so the answer would be 3 pi over 2 plus another revolution. It's coterminal. The answer is going to be 7 pi over 2. There are your two answers for this question.
Can you shift it up a little bit?
Yes. There. You might have noticed by now, some of you are looking at this being fairly new to a lot of you, in fact, all of you. Some of you might still be looking at this like, okay, so in that situation I do this, in this situation you do that. It's true, but what I'd like you to get to as you practice this is not look for specific steps to follow, but generally speaking, right, you're doing the same thing. How you accomplish it might be a little different. But every single question, we're trying to figure out, okay, where are the quadrants that we're interested in, and what angles should we be looking into? Like, how you accomplish that, if you're really interested, you might even be able to squeeze in like cofunctions and whatnot here if you really wanted to. But of course, it's not efficient, so you don't. The choice is yours. Okay? It's 9:50. In about 10 minutes, our football people have to go. How's this? Instead of forcing you to go through more questions with me, I'm going to ask you to try on your own example 5. And then after I give you about 20 minutes, we'll go for our break. We'll come back, take up the last 2 examples, and then maybe do an example or 2 of rate of change to finish off the day. Okay? Just to give you a heads up of how you can start this, remember that we can substitute, sine 2x. This is going to be the same as sine a squared minus 3a plus 1 equals a 0. Which is equal to, you guys are fine, it's not so bad.
Is that sine squared 2x?
No, so sine 2x. Eh? Really? What does it say for yours? Oh, yeah, that's a different one. Okay. So that would be -1 and -1. Give it a shot. What does that mean? And where do I go? I gave it to you. I gave the domain to be a little easier for you. It's 0 and 2 pi, so just one revolution. At least one circle. But you'll see that there's more to it. Let's see how well you can do. Guess I'll stop this video, or pause it here.